Okay, good morning everyone. Good morning everyone. I am Mr. K.V. Rao, working as assistant professor in Lawrence Marriott Engineering College. Today we are going to see about the topic semiconductors, that is what are semiconductors and types of semiconductors in detail. Okay. Right. What are semiconductors? Semiconductors are nothing but the solid state materials which acts as insulators at low temperatures and which acts as conductors at high temperatures. So if you see, solids are classified into three types, namely insulator, semiconductor, conductors, depending on their electricity property. But in this semiconductors means, okay, the solid state materials which partially allows the flow of current through them are called semiconductors, right? And their resistivity and conductivity values lies in between insulators and conductors. Insulators are the materials which doesn't accept flow of current through them at any temperature. Conductors are the materials or solids which can accept flow of current through them at any temperature. In between these insulator and conductors, there is another classification of solids, that is semiconductors. Right? If you see in energy level diagrams like conduction band and valency band, the gap between this conduction band and valency band is said to be energy gap. Right? Gap between conduction band and valency band. What is conduction band? What is valency band? The group of energy levels of valency cells of all the atoms is said to be valency band. Conduction band contains energy conduction levels of all the atoms in a particular substance. That is, group of conduction levels is formed conduction band. Group of valency energy levels forms valency band. In between these two, there is a gap that is said to be forbidden energy gap or simply energy gap. So this energy gap is huge for insulators. This is minimum for semiconductors. There is no energy gap in case of conductors because of valency band and conduction band merge, overlap with each other. Right? If you see the second point in that introduction, there is a large gap between valency band and conduction band, whatever we discussed earlier. Right? Okay. Next, the electrical conductivity of conductor decreases with increasing temperature. Earlier, I mentioned a point, that is, there is no forbidden energy gap in conductors. Right? Whenever we give some temperature, that temperature, rise in temperature causes some heat and which can break the bonds between the atoms. Then we can observe the free electrons in any case. But here in case of the conductors, when we increase the temperature, then their conductivity decreases. But whereas in case of semiconductor, if temperature increases, their conductivity also increases. Right? It means when temperature increases in conductors, then their resistivity also increases. Whereas in case of semiconductors, when temperature increases, their resistivity decreases. That's why you can say semiconductors has negative temperature coefficient and the conductors have positive temperature coefficient. Right? And now we got one definition, that is, semiconductors are the solid state materials whose resistivity and conductivity values lies in between semiconductors and insulators, right? Conductors and insulators. And the forbidden energy gap is about 0.2 electron volts to 3 electron volts approximately. In conductors, that is 0. In insulator, that is more than 3 electron volt or 3.5 electron volts, right? So again here, conductors, examples of conductors are all metals, insulators like plastic, rubber, wood, etc. And semiconductor examples are, best examples, silicon, germanium, right? Carbon also one of the example. Right, here again, semiconductors are classified into two types: pure semiconductor and impure semiconductors. Right? Pure semiconductor, impure. It means depending on the atoms exist in the particular semiconductor. That is, if only one kind of the semiconductor elements present, then we can say pure semiconductor. If any other atoms added to the pure silicon or germanium, then we can say they are impure semiconductors. Right? Pure semiconductor, impure semiconductor in general language, but in technical we can say intrinsic semiconductors and extrinsic semiconductors. Intrinsic means pure, extrinsic means impure semiconductors. Right? In a pure semiconductor, that is in intrinsic semiconductors, all the atoms bonded together with covalent bonds with its surrounding 4 atoms. Right? Whereas in case of extrinsic semiconductor, means we are adding some impurities. That process is said to be doping. Doping, right? Okay. Doping is nothing but adding impurities to pure semiconductors. Right? At 0 Kelvin temperature, there are no free electrons in the conduction band, and hence electrical conductivity of pure semiconductor is 0 because of all atoms bonded together with covalent bonds. That's why there is no free electron. That's why at 0 Kelvin temperature, there is no electron present in conduction band. Electrons present only in valence band. As temperature rises, as temperature increases, then covalent bonds between the atoms breaks and electrons becomes free to conduct the electricity. Then we can observe some electrons in the conduction band. So if you see here, we are having all silicon atoms bonded with covalent bonds. We have given dotted lines and 2 electrons between 2 silicon atoms anywhere. That is an electron pair shared between those 2 silicon atoms. That's why each silicon can pair with 4 silicon atoms of its surrounding nature. Right? Then as covalent bonds are breaks, then electrons moves to conduction band. Right? In case of intrinsic semiconductors, number of electrons, free electrons in the conduction band, number of electrons in the conduction band is equal to the number of holes in the valency band. What is this hole? It means missing of an electron is said to be a hole. Electron having negative charge, holes having positive charge. Electrons carries negative charge, holes carries positive charge. And these 2 electrons and holes are said to be charge carriers. Charge carriers. The electrical conductivity must be due to electrons and holes, both in any semiconductor device, that is intrinsic semiconductor, extrinsic semiconductor. Right? In case of intrinsic semiconductor, number of electrons in conduction band is equal to the number of holes in the valency band. Right? Now, this is because of at 0 Kelvin temperature, there are no electrons in conduction band. That's why whenever we give some temperature across the material, it means whenever we give some thermal energy, then only covalent bonds breaks and electron jumps to a higher level, that is conduction level. That's why if one bond break and 1 electron missed in the valence shell, then we can say the 1 hole is existed, then 1 electron is present in conduction band. That's why number of electrons in conduction band is equal to number of holes in valence band. Right? Energy level diagram for intrinsic semiconductor. So see on the left, we are having all atoms, electrons in various valency levels, that is valency band. In top conduction band, there are energy levels, there are no electrons. The gap between these 2 is called energy, forbidden energy gap, or EG. In between conduction, bottom level of conduction band and top level of valency band, we are having Fermi level. right? Right side we are having sun. When we increase temperature, then we are having electrons, 6 electrons in conduction band, 6 holes in valence band. That's the number of electrons in conduction band equal to number of holes in valence band. Right? Whereas in case of extrinsic semiconductor, extrinsic semiconductor means impure semiconductor. There are two types of extrinsic semiconductors, namely N-type semiconductor and the P-type semiconductor. N-type semiconductor means, right? N-type semiconductor means negative type semiconductor. That is, we can obtain this by adding pentavalent fifth group elements to pure silicon or germanium atoms. Right? If we add trivalent, that is third group elements as impurities to pure silicon or germanium, then it gives a p-type semiconductor, that is positive type semiconductors. It means when we add pentavalent, that is when we add fifth group elements to pure silicon germanium, 4 valence electrons makes 4 covalent bonds, 1 excess electron will be there. That electron is freely, not bounded, loosely bound with that atom, like phosphorus, aluminum, okay, those. Then whenever we give small amount of thermal energy, then that electron should be present in conduction band. There is no holes, it means there is no missing of electrons in the particular bond nature. That's why if we take one impure atom, then 1 electron will be there. If you take n number of atoms, then n number of electrons are already there, even in the absence of holes in valence band. That's why number of electrons in the conduction band are more than number of holes in the valence band in case of N-type semiconductor. Same in case of P-type semiconductor, if you add a trivalent, that is 3 electrons, 3 electron pair can make 3 covalent bonds with surrounding silicon atoms, and one missing of electron pair, that is small amount of positive charge will be there. That's why whenever we give some thermal energy, then initially bond breaks and that electron should be occupied this missing place. Then afterwards it should be shifted to higher level conduction band. That's why initially there should be some positive charge, that is the holes present in the valence band, missing of electrons. There is no electrons in conduction band. That's why here whenever we give some thermal energy, then more number of holes present than the number of electrons in conduction band in case of P-type semiconductor. This is about the basics of semiconductors. Okay, thank you. We'll see it later.